In Australia's busy urban areas, traffic congestion is a major problem, leading to frustrating delays and longer travel times. City planners and engineers invest in improving road infrastructure, but delivery services also face challenges. To solve this problem, we've developed a solution: computer vision for drones. By swiftly navigating through airspace and avoiding traffic, drones offer a unique solution for faster deliveries, addressing issues like slow delivery times, rude driver behavior, traffic congestion, and pollution. Our computer vision for drones aims to revolutionize the delivery industry, creating smart drones that recognize and maintain a safe distance from other drones. In our demonstration, we employed a YOLO V5 model specifically designed to detect drones and accurately calculate their distances from the camera. To replicate the real-world scenario, we utilized a camera as a substitute for a UAV drone. This allows us to showcase the capabilities of our model in identifying and tracking drones, enabling precise distance estimation. By utilizing the camera as a stand-in for a drone, we can effectively demonstrate the potential of our technology in drone detection and distance calculation, opening doors to enhanced aerial surveillance, safety measures, and innovative applications in various industries. Here is our website showcasing the workings of live detecting and estimating the distance between itself and other drones, as well as image classification detecting other drones. Let's begin with live drone detection. You can adjust the camera focal length and object width settings for accurate distance estimation. If you're unsure, however, hover over here for a brief explanation. Alternatively, you can leave them blank, and our website will use default values of 50 mm for camera focal length and 500 mm for object width. Scroll down to find the Start AI button. Click it to activate your camera for drone detection. Hold up an image or YouTube video and it will automatically detect the shown drones and estimate their distances. Pretty cool, right? Next, let's explore the image detection feature. Here you can upload one or more photos of drones, and the website will detect the drones in the images. For example, let's upload 5 drone photos. After clicking upload, the images will be processed. To witness the image detection, simply click Start. Now navigate to Result Images to see the detected drones and their distances. Overall, our website showcases the possibility of bringing this idea to life, and this is what it would look like in real-life scenarios of how drones can become automated. We are Smart Travel, a group of 3, Grace, Dominic, and Angus. We believe automated vehicles and drones are the future as they provide faster delivery, avoiding all traffic, reduce carbon emissions, and remove the need for human drivers. So no more complaints about rude driver behavior. The big question is, do you want to be part of the future or do you want to resist the future?